Good morning, ladies and gentlemen. Welcome to the day 3 of 4th edition of Cypher 2018. My name is Safir. I'm going to be the host for the day. One trouble to the people. Okay, first of all, people who have come here on time, you deserve a big round of applause. Why don't you clap your hands for yourselves? You are amazing. Now, little trouble I'm going to give you is let's move to the front, please. Let's move to the front. Front 2-3 rows are very special, reserved for the people who come on time. Why do you want to be at the 4th or the 5th or 6th row? Get to the front, fill in the gaps, close to the speaker, better information you can grab, more face-to-face interaction. Perfect. So ladies and gentlemen, without much of talking, I'm going to be introducing you to our first speaker for the day, Mr. Venkatesh Sunkad. Dr. Venkatesh Sunkad is a mentor at INSOFE and has over 20 years of experience in telecom, cable, wireless, and IoT industry. His core expertise lies in IoT and Industry 4.0 focus areas. Talking about his experience, it includes a formidable combination of training, consulting, and helping industries and business in various technology and strategy challenging areas. The topic on which our first speaker for the day will be talking on now will be IoT and data intelligence in Industry 4.0, myth or reality. Ladies and gentlemen, I know we all did it, but do it once again with me. Help me in welcoming our first speaker for the day.
Thanks.
Thank you.
So before I do anything, can everybody hear me? Yes. Okay, perfect, guys. First of all, again, thank you very much. Beating the traffic and coming at 10 is not a joke in Bangalore, so first of all, thank you very much. It's appreciated, provided, depending on where you live. So just let's get into the topic. So let me stand here so that everybody can see me. So quickly, I wanted to talk about Industry 4.0 and IoT. So let me explain what Industry 4.0 is, and so that you can understand what that is, and we'll go through the presentation. So as you can see, there are four sort of major events that happened from if you take from mankind. Industry 1.0 was basically when steam engine was invented. What happened when steam engine was invented? People could move to a lot of different places very fast. Industry 2.0 was when electricity was invented. Electricity and this mass production happened. Mass production as in, basically you could do this mass production happened. So that helped people to produce it massively products. Industry 3.0 is which we are sort of living right now and entering Industry 4.0. Industry 3.0 is when the whole internet sort of the game came into picture. This whole internet thing that started, the way I call internet is a very quick way. There are 4 stages for internet. One, if you remember, and I don't know, I see a lot of young kids here, so maybe you may not remember, internet started with Internet of Pages. What is Internet of Pages? Remember in the 90s, you just had a page and you had to go it and everything. Next, it started with the second thing I call it is Internet of People. That's when the social media started. So people started talking to each other, and they basically could actually understand each other and sort of have it thing. The third thing is what? The Internet of Things, where it is not just people talking to each other, but it is the machines and the people talking to each other. That's called the Internet of Things. That's how you take the Internet evolution. That's how the Internet got evolved. And that Internet of Things combined with combination of artificial intelligence or whatever you want to the name, machine learning. There are a lot of names that you want to give. In addition to that, the data analytics is what Industry 4.0 is all about. So let me go to my next slide. If you look at my next slide, basically I want to talk about what are the elements of Industry 4.0. So there are a lot of elements for the Industry 4.0. First one was, basically you have this big data. So there's a lot of data that has been generated from Industry 3.0, the knowledge and everything. This is the first time that they wanted to see, I have this data, whichever industry it is. Technically Industry 4.0, the term was developed in Germany for actually manufacturing. But if you look at the way Industry 4.0 has evolved, it has evolved into every field that you can take a look. It's not just industry, and I'm going to give you examples in my presentation that talks about how Industry 4.0 can be used in things that even when I was doing research for this one, I was amazed. So let's do that. So that's the big data part of it. What is an autonomous robots or autonomous systems? So we are developing this new breed of systems where human intervention is less. There's a lot of things that our machines can do with each other. That's one of the primary things of Industry 4.0. The next one is IoT, Internet of Things. What is Internet of Things? Basically, from an explanation perspective, Internet of Things is anything that can collect data. That's what I saw it in a very common way. What is Internet of Things? Internet of Things is nothing but things that can collect data. Once I collect the data, what do I do? That is where all the analytics, the artificial intelligence, and all the other things come into picture. Next, system integration. This is a very key aspect of Industry 4.0, because now I'm not just integrating a process, I'm integrating multiple systems, meaning I'm integrating an existing, a factory or an existing machine or an existing equipment with new systems that didn't exist earlier, and they should work as if it is one system. And finally, security. Most people do not, whenever we use the Industry 4.0, they exclude one thing, that is security, because end of the day, more and more we're reliant on machines. Security plays a very, very critical role in terms of understanding it, what is the security piece of it. So basically, Industry 4.0 is nothing. This is the, okay. So anyway, I can point it, I think, because somehow it's, okay. Services are delivered through a common transport, which means to say, irrespective of whatever your services are delivering, the transport is the same. Second thing is, data is shared across all applications. That is one of the key parts of Industry 4.0, that the data is across applications, it's shared. Irrespective of how it is that either it is the formatting part of it or anything, the data is shared across different platforms, and the customer experience, from a customer perspective, whether the customer is a human or a machine, is same across whichever industry you take. And that is sort of a very high level what Industry 4.0 stands for. So let's take the next slide, where what I have done is sort of a layered architecture of what Industry 4.0 is all about. The first one is you get the sensors. You have the light sensors, which could be temperature, light, whatever it is. But then you have something called the actuators. This is the IoT components. So basically, what is a sensor? Sensor basically tells you what the data reading is. Actuator is something where actually the action is done. So for example, let's assume that you have a thermostat. There's a sensor that tells you the temperature is, let's assume, 30 degrees Fahrenheit. The actuator is something that actually gets it to either turn off the thermostat or turn on the thermostat at a very high level. Next, you have the access, which is very critical. How do I communicate all this information I'm getting? So there are different ways you can communicate it. One, either it could be cable, cellular. So there are a lot of ways you can communicate the information. So including, for example, NB-IoT, which is one of the things that are coming in, which is called narrowband IoT. So if you have heard about the 4 phases or the 5 phases of cellular communications, and they're talking, it's now 5.0. Basically, NB-IoT is narrowband IoT. It's a very special thing that they're actually doing the standards, which basically they're telling for IoT what are the standards for, and it's called narrowband. The reason why it's called narrowband is most IoT applications don't need a lot of bandwidth. If you take the 5G applications, the bandwidth is huge, because if you look at the spectrum and everything, it's huge. So they are trying to do narrowband IoT. It doesn't have to be 5G. Even in 4G, you can do even between the spaces of 2 frames for LTE. If you're familiar with LTE, they're trying to do. The next level is where it's the core. That's where the system integration, the PLM of the machines, the data aggregation, the service delivery, the routing, and the QoS, which is the quality of services based, which is sort of acts as the core for any Industry 4.0. Next, above that, you have all this information. What do I do with that information? You have analytics, machine learning, insights, stream processing, everything that is basically the analytics piece of it. Next, you have the customer layer, because you have to develop applications. End of the day, applications have to be developed on Industry 4.0. So what is the application layer for Industry 4.0? And finally, you have all the applications. One more thing is, even though the word is called Industry 4.0, the term is generically used for any applications that we have this complete stack. So it could be a home application, it could be a healthcare application, and throughout my presentations, I will take a few applications and say, how is this being used? Or it could be a transportation. So any one of these applications, this is there. But this is incomplete without a few things. First thing is device management plays a very, very critical role. How do I manage this hundreds or thousands of devices, that sensors, or it could be actuators, or it could be anything? How do I manage them? Next, how do I manage the data? It's not just the data that I collect from the sensors, but the data I already have. How do I integrate it? How do I manage it? Finally, there is something called gateway. So what happens is there's something called edge analytics. What is edge analytics? A lot of these decisions, especially in IoT, need not always happen to have at the cloud. So there's a lot of things that can happen. So for example, I'll give you a very simple example. Let's say you had a smart device in your home, and let's say water started leaking from one of the pipes. You don't want something to go to the cloud, understand it, and then tell your water to shut it off, right? You want a device, something called a gateway within your home, immediately to understand it and just shut it off immediately, and then send the data to the cloud. That's okay. But you need that. And that is what gateways agenda is. Either it could be an industrial gateway, an enterprise gateway, depending on the application. But all this is not complete. Again, guys, security has to run end-to-end. Without security, because more and more critical data are now running on Industry 4.0. So this is very critical that the security actually runs across the entire picture. If you have questions, hold on to your thoughts. Let me finish it, and definitely I'll be open to any questions that you guys have. So what I wanted to do is, in my next few slides, is basically talk about few applications of how, So I have 2 slides for each area. First, I'll talk about how it is at a very high level, how it's been used. Then I take a very specific example and see how it's been used. So smart agriculture. Smart agriculture is not new, but it's been there around for a long time. But again, it's gaining importance. So there are 2 major components for a smart agriculture. The first thing, it's called precision farming. What is precision farming? Precision farming is a technology that basically involves a lot of things. So let's basically, first thing is remote sensing and sensors. So what they're doing in farms is basically they have a lot of these sensors to understand the soil quality, to understand the moisture, to understand when the crops are raised. This is farms we're talking about, especially in US and everything. These are not acres. These are 1,000 acres, 2,000 acre farms. These are huge farms. It's managed by 5 people or 6 people. So second thing is high precision positioning systems. They're either using satellites or they're using drones to basically go through the entire farms to understand what is the state of the farms, where are we, things like that. Next, geomapping. Why do we need geomapping? The reason why we need geomapping is basically they want to understand where are my crops, where I can plant my crops across this, what's happening to my fields. So the entire thing is now being mapped by geomapping. Next, automated steering systems. So obviously you have autonomous vehicles that are actually doing a lot of this agriculture. Variable rate technology. What is variable rate technology? So for example, let's assume in a farm or in a grass, you have different crops you have put. You don't need the same amount of water that needs to go into the different parts of the crops. Variable rate technology basically tells you how much of water I need to put based on these autonomous systems. And finally, integrated communication systems to meet all this, and basically one unit that I can monitor from where I'm sitting to do the entire farming. That's something it's called precision farming. But equally important to that, plus cargo monetization, and I have a use case for this. Once I do the precision farming, the most important thing is from farm to market. How do I take it intelligently from farm to market? So I will talk about this more in the next slide, so I will not talk about that. So how is these 2 being done? 2 things it's being done with the use of IoT, big data, and machine learning. How do I do IoT? IoT is basically all the sensors that are being done. The data is basically all the data that I'm collecting. Machine learning or artificial intelligence is basically the decisions I take from what type of farming to what are my predictions to say. For example, if I put this, what happens next? That is what machine learning is being used in the farming. Finally, all this integrates into something called an intelligent agriculture. So let's take a specific example and see how it is being done. So I took an example and I call it farm to market. So obviously you have producing farm, and let's assume this is a produce that's been produced. What's the next thing? The next thing is you have to put it on refrigerated trucks. What I have done here is I only talked about the intelligent, what are some of the intelligent sensors and how are they being used. There are a lot of sensors on these trucks. 2 sensors. First thing is obviously you have the humidity sensor and you have the temperature sensor. Obviously to know the temperature of the truck, which goes to cold storage. The second one is GPS. Why GPS? The reason why GPS is being used is these trucks next actually go and deliver it to a place called food packaging. So the GPS helps you for the food packaging to know exactly where the trucks are, when the trucks are coming into my location, so that I can start my processes from the people, how much people I need, so that exactly when I can, so what happens is from farm to market, you need the least amount of time. You don't need a huge amount of time depending on the produce. So that's what GPS helps. Now let's take food packaging. Obviously, again, you have the temperature sensor and this. That's okay. But there are two very important ones. And when I was reading this, I was really, I liked it. There's something called a smell sensor. So now what they're doing is, especially for meat products and everything, during the packaging, they're adding something called a meat sensor, or smell sensor. Basically, that tells you whether the meat is good or bad. You don't need a human or anybody to tell you anymore that the meat is good or bad. You have something called a smell sensor. Actually, it's a thin RFID, thin flame that actually goes into the packaging of each, and it is tuned for each product. So based on how it smells, based on the chemical reaction that when the food goes bad, it reduces. That's what they're targeting. Next, they have an RFID. Why do I have an RFID? Obviously to know when it was packaged, how long it was packaged, things like that, the standard things. So from the food packaging, where does it go? Again, there's a truck that actually takes it to the thing. In the truck, they're using something called a freshness sensor. What is a freshness sensor? They know how long it takes for them to travel from point A to point B on the truck. So they know what products to load on the truck based on this freshness sensor, so that the next time it reaches a cold storage, they know exactly what state it's in. Then they go to a cold storage. Here what they're doing, obviously the temperature and humidity is common, and it's something that's common everywhere, so I'm not going to talk too much about it. They're going to use photoelectric sensors. Why photoelectric sensors? Because in this cold storage, what they're doing is, one of the things they're doing is each shelf now in the cold storage. Earlier cold storage used to have it, I have one shelf with 6 shelves. All 6 should be in the same temperature. Now with the help of photoelectric cells, what they're doing, and this is something that is not theory, Walmart, big guys, Amazon, are actually trying to implement this. It's actually being implemented as we speak. It's not something theory that it's nice to have. So this photoelectric, what they're doing is it maintains the temperature for each shelf. So they can have different products for each shelf. Next, finally, it goes into your grocery stores, whichever grocery stores you have. Again, there are 2 things here, and I just gave you an example. One thing is, now the packaging, they also have another sensor that tells the consumer that is this good, if product is bad. The next one and that's my personal thing is, I saw something called, this is to detect in the wine bottles. They're using new sensors, basically to tell if the wine bottle has been tampered or not. What is happening, it seems, and there's a lot of fake wine bottles are coming, it seems. Especially they're using the wine bottles, and they're removing it. Actually, the bottle is the same, then they're pouring, So they have this NFC device sensor on the wine bottle. What it does, the moment you try to open it, it will tell you it's NFC based. So if you just take it near it, or what they do is they run this wine bottles in an assembly line. It will automatically start detecting and tell you if the wine bottle has been opened or not from the time it has been packaged. So grocery stores are using that to tell you whether there's a tampering in the wine bottle or not. Okay, I'm sorry, you had a question? Hold on to your questions. Let's do it so that the flow happens. I will ask you all your questions. I'll be happy to answer. So that the flow happens, and then do it. So that if not, the flow. Definitely hold on to your questions. I'll be happy to answer it. So how is all this possible? Obviously, there are 2 things: IoT, big data, and AI. The way I compare it, and I compare it to a human being. What happens? What is IoT? IoT is all your veins. That's where all the blood goes in. That's the data information. What is data analytics? Data analytics is your heart. What does your heart do? Heart does 2 things, right? It separates the bad blood and the good blood. Similarly, what does data analytics do? You need to know out of all the data I have collected, what is relevant data, what is non-relevant data. That's one of the primary focus of big data. How do I separate my good data and my bad data? And finally, decisions has to be made. That's your brain, which is your AI. So I think about it as a human body. This is what the data and the whole thing has been presented in terms of farm to market. The next application I talk about is called digital twin. How many of you have heard about the word digital twin? Yeah, quite a few, right? It's a concept that is slowly evolving, and I think for 2018, they said one of the top 10 concepts of technology is called a digital twin. So let's go through it and say, what is a digital twin? So what is basically a digital twin is, you have a physical version of a machine or a process. Let's say it is a machine or a process that you have, which you have a physical machine. What you do in the digital twin, and there are various phases for a digital twin. Let's go through it. First thing is, even today, you have some amount of simulation, right? You can simulate a machine. You can actually understand what the machine is and things like that. So that, what I personally call it, it's a digital version minus. Basically, you can do limited things on the machine. Basically, you know that if I do this, this will happen. But at a very limited scale, you can do that. The next level, what happens is, imagine now the actual physical machine, with the help of sensors and everything, start feeding in data to your digital version, which is an exact replica of your, physical machine. Now what happens, you're not anymore simulating, you're getting the real data from what it is being, for example, let's assume it could be a building, it could be a machine. Now you're getting data from the actual machine. So your data is a lot more authentic than what you used to earlier try to do the simulation. But then, the last, which is what a digital twin is. A digital twin is an exact virtual replica of your, physical version, which means to say, the information is not one way, now the information is two way. Earlier, for example, when I said the digital version, the information is only one way, which means to say from your physical actual machine or building, actually let's assume it's a building and you have a virtual building. The information went from a building to the virtual thing. But now, digital twin it's an exact replica of what you have, so that you can do a lot of things. So for example, production and design. So for example, any things that you wanted to experiment on your products, now you don't need to stop production. You can use the real data that has been fed from the physical device into your digital twin and try to experiment with it. For existing products, for example, if you want to deploy something, you don't need to anymore deploy it and say, why, I don't know, I have the simulated data. There's no simulated data anymore. It's the actual data that you have on a digital twin. You can use it to actually deploy it, see how it works. Next, future products. Designing of future products in terms of what can I do, how does it interact for different types. That is what you can use using your digital twin. How is this, powered? There are 4 things, standard things. First thing is IoT. That's where the communication happens between the physical thing and the digital thing. Virtualization, or you can call it, which is a very important thing. So the maturity of augmented reality, which is what is basically helping a digital twin, is no more it is, just a diagram, no more it is just a thing. It is actually a replica of what you have on your physical entity, which means to say it is exactly at that, but in a digital version. So you can get whatever changes you do here, it is exactly as that something that you can actually what's happening on the real. And that helps you because of augmented reality. Next, edge versus cloud. Analytics, very important. There's a lot of things that you do at the edge. Analytics, that can also be tried out in the digital twin. Try it out, see how it works. And if you want to develop a new feature or deploy a new feature, you no more do a simulated version and say, let me do it on the real thing. You can really know what the interaction is. If you want to increase the load, if you want to increase anything, you can do it. And that's what analytics. And finally, AI is what if. The way AI deals always it is what if. What if this happens, what that happens, that's what AI deals with. So this is sort of, basically a digital twin. And then what are the benefits of it? As I told you, visualization, collaboration, and find product line engineering. Any new product development, this is a huge benefit. Basically, you know how it reacts, how do I change it? The next, basically an example of a digital twin. So I took a museum, so how many of you, most of you must have heard of the Louvre Museum in Paris, right? It's a very famous, the University of Chicago. They're actually doing this. What they've done is they've actually created a replica of an exact augmented reality of an exact museum that they have. So the first thing they're doing is, what is the goal of any museum, right? There are 2 goals. One, get footfalls into the museum. Obviously, footfalls indicates revenue. So how do I do that? There are 3 things that they're using. First thing, they're calling it as art attention score. So I've taken examples, guys. One thing I've done is, and I've taken examples which are not common. I didn't want to take an autonomous car. I didn't want to take these things because I'm assuming there are enough speakers who spoke about those things. So I wanted to take something that is offbeat. So I've taken examples that are different from, generally you don't hear about it, So what is an art attention score? So the moment you enter, what nowadays are doing, basically they're giving you a strap in Louvre or something. What it helps you, the strap with all the sensors, and at the moment you enter the gate, they know how many people not just entered the museum, but each space meaning each, what should I say, room that has the gallery. They also know how many people entered the room, how many people exited the room. Why do they need it? The moment they need it is basically crowd management. They really, if you can understand how many people are rarely going to one or two rooms, or are they actually going around the museum, because that's very important for you to understand how do I distribute my paintings, how do I distribute my art. Now, how are they doing it? Obviously, and they're also saying, if I change this, what if, and that's what the... Next, they're also using something called a real-time visitor location tracking. What is that? Basically, what they're telling is they have sensors on the, what should I say, on the roof or on the ceiling, which actually talks to your badge. What they're trying to say is, I want to know how much time people are spending on each art exhibit. So obviously, when you go to a museum, you don't spend hours on every art exhibit, right? Until and unless you're a real critic or something. You pick 4, depending on each individual taste. You pick 5, depending on each individual taste. They want to know how much people are spending on each art exhibit. How do they know? Based on how much time you stand there, so that the next location I know, the next location I know. So that helps them to design. If too many people are spending on room, and so that how can I design the art? Then they're taking it to the next one, which what I thought was pretty cool, me personally, something called an art emotional score. What they're trying to do is, they put these miniature cameras in every art painting. Why are they doing it? So they want to capture your emotion. When you see this painting, they want to know whether you're happy, whether you're sad, whether you're happy, sad, what is your emotion? The reason is they've said that they don't want to put two sad, what should I say, if you're very sad with that painting, they don't want to put two sad paintings next to each other. The reason being, they say if that people get dejected and walk out of the museum. So they want to put a happy, sad kind of a thing. So they're actually capturing the human emotions to understand what do you do for each painting. And how, and all this is possible through digital twin, because they can replicate it through a digital twin and understand what if I can do this, what if I can do that. That is what they're trying to do with the new edits. So they don't need to wait for people to do it, but they can replicate it using a digital twin. That is what, and now basically a future museum will be look like that. In fact, a lot of these pieces are already being implemented. University of Chicago, Chicago Museum of Art, Louvre. There's a lot of places where this is being implemented. But this is really, something that is, you think, generally AI is something that you do it in groceries or in tracking, but this is something where you don't even imagine that AI or IoT can be used. They're using it. Next is basically I want to talk about the new medium, and then I have 9 to 10 minutes, so I think I'll have enough time for questions and everything. So what is the new medium? All of us are familiar with the streaming services, right? Be it Netflix or Amazon or whatever. We are familiar with the Netflix services. Whenever you go and log into it, how are they, what are the services they're being offered, and how are they tracking you? So let's start with, first thing is, whenever you log in, you find something called a personal, either it could be books or writing. They find a personal video ranker. What is a personal video ranker? Based on your choice, what you have watched, similar to what others have watched, they give you a list, which is a personalized list for each one of you guys. Each one of us will get a personalized list, which is different from your neighbor to a neighbor depending on your choice. How do they do it? Based on AI. What do? They rank, basically they have the data. They say if he has watched this, what are the chances of he watching this based on certain categories, certain things. Next, what is a must watch? Among that personal, they give you what are the top 10 that other people are watching, so that based on your choice, and that's called a must watch. Then their next level they're going into is called what are the popular series and things like that they're doing. The next thing is watch later. This is a very interesting thing. Let's assume you watch a video, right? And let's say you watch it for, let's say it's a 2-hour movie. You watch it for 10 minutes and walk away. 2 reasons why you walk away. A, you were interrupted because you had some other work, or B, you didn't like it. They have done research to say if you like a movie, within 72 hours, you'll come back and watch that movie. In most cases. So that is how they're seeing, what are the chances that you watch that movie. So what they do, they still keep it in your personal video ranking for 72 hours. Then they remove it. Because they know you're going to watch that movie. So they go to that level of understanding of what your habits are. How do they get the data? That's a different question. We provide the data. It's not like they wake up the data. That's a different question. How do they get the data? We are the data. They get the data from us. Next. One more great thing is, no more the language is a barrier. If you like, let's say, assume in an action movie, they're now going to show you action movie with English subtitles in any language. Earlier, you had to know French, you had to know German. Nowadays, it's anymore not possible because now you have the entire movie audience with you. Any language you can watch, as long as there are subtitles. Obviously, there are subtitles so that you understand it. Whatever language, let's say you're French speaking and you have an English movie, you can have French. So that amount of, what should I say, it's available, which was not available earlier. And finally, the next big hit. What is the next big hit? Based on the user preferences, Netflix, Amazon, everybody are now providing their own content. How are they providing the content and how are they picking what is the next content? Based on what we do. They know what is the next big hit. What is the measurement or the ratio of that? What are the types of things that they needed in order to pick the next big hit? So we are actually providing the data to provide the next big hit. It's not like they're earlier movies, what they used to do, they have to sit, think, here the data is already available. So the next slide is basically, a video. The speaker needs no introduction. What I wanted to say is Industry 4.0 or this new thing is not just limited to technology, it can be anywhere. Okay, can I play the video? How do I just? Okay, I'll just move out.
Last night I was with my friend driving with him and Ajay was very disturbed because he owns this big chain of theaters where he was talking about the fact that no footfalls are coming into cinema theater. But whatever we are going to lose out in the conventional sense, we are going to gain in terms of attracting more eyeballs through big data. So that's going to be the big business of the future as far as cinema is concerned, especially in a country like ours, where we still have a huge untapped market in digital consumption. The second change that is going to happen is that there is going to be the radical movement away from the content itself. Movies are going to be shorter, I think. They will be without intervals. And instead of stories being based on physical geographical boundaries, they're going to be based on more social and psychological geographies. Because everybody will be available, talking, exchanging ideas on the digital world. And because of this flow of ideas being uncontrolled and going on as it is, anyone can make a movie in the future, what's going to happen is even big production houses are going to suffer. They're going to completely break down. Power will not be vested in the hands of you like me, or I won't name other production companies, I just mentioned myself, but all other production houses. Because there will be a more democratic process via which you will understand the demand for the kind of cinema. Because the audience will take away, send your feedback like it already does on Netflix. Also, I've mentioned this before, instead of all of us waiting for money or taking loans, what is going to happen is there's going to be a lot more crowdfunding. The third thing that is going to happen is between the viewer and how we watch the film. That is going to be a big change. Right now, whenever movies attract us, it's a momentary catch of emotion or an experience. But soon, movies themselves will become the experience. They will be interactive. You will sit down, you can change the endings, you'll be able to change the characters. You can watch different films, your children and your family, while watching the same film, you can follow different storylines. All this is going to add, of course, value to entertainment and how you're going to watch it. But these changes are really going to radically change everything that you believe in. So, for example, by the time I go down 6, or I tell you, कि वो क्या 11 मुल्कों की पुलिस डॉन को ढूंढ रही है, अबे बुढ़ा हो गया, पुलिस में कहाँ इसको ओल्ड एज होम में डाल दो. And you can change it. One request I'm going to do to my friend, Sunkad. I love him. But जब उसकी अगली 33rd version of Tiger जिंदा है आई, और जब वो 2000 करोड़ रुपए कमाएगा, तो मैं उसको पढ़ जाऊंगा, मामा बोलूंगा भाई, Tiger को जिंदा रहने से रिटायर हो जा. So we can change all that. One other thing that is going to happen, honestly, is I think artificial intelligence, virtual reality, and visual effects.
So on and so forth. That's a big video. I don't want to play. So basically, you can see things that you can never expect, right? That media movie industries, everybody is thinking about it. This is not something that is, limited to some research lab somewhere, but these guys are also thinking, how do I do the next big thing? And this is what Industry 4.0 is all about. Thinking in areas that you would not imagine, right? I don't think, I would have thought Shah Rukh Khan would have thought about big data or anything, but he's thinking about it because he's a smart businessman. This is what, the end of today is what big data, or this is what Industry 4.0, it's not a myth, but it's a reality. So I have a few minutes, and can I extend it for a few questions? If that's okay, obviously I'll ask the, I'm sorry, sir, go ahead. Smart agriculture, right? So the business cases depends on the size of the farm. Obviously, if you have a very small farm, smart agriculture will not be a great thing. We have some numbers, and I have read some numbers, especially if they say if the farm is bigger than, like 30 acres or something, then there is a business case for it. If it's less than that, it's tough because the amount of energy you want it to be, especially in a country like India, if human labor is cheap, then it's tough. But if you want to manage in the next generation where the human labor, if you want to maximize, then there's a good business case for smart agriculture. It's generally about 25 to 30 acres is what people have told me, which is a very few farms. The big farms is what it is. An average farm is an acre or 2 acres if you look at it. But most cases, today, because the price of what the technology is, obviously tomorrow if the price of the technology comes down, it changes. It obviously changes. Good, thanks. I'm sorry, go ahead.
Hi, Venkatesh. One question.
Yeah, go ahead.
In the endless debate between technology versus adoption, my view is when you look at IoT from an AI perspective, technology has existed for some period of time, a few years. But the real challenge comes from cost versus the adoption and behavioral acceptance of this into real life situations itself. So my question is, what's your view on this perspective from the examples you've shared?
Exactly, right. So, very good question. And I'll give you an example so that, I don't name a company, but all of us know. It provides 4G services, one of the new ones. And the way they market it to the rural crowd is TV without bijli. So what they say is, guys, in rural areas, you have 14 hours power cut or 12 hours power cut. All you need bijli is to basically charge your phone. Once you charge your phone, that's it. You can watch TV without bijli. So that is how they market it. So to answer your question, adoption is depending on how you do it, right? So that's how they do it for this company. And again, I don't want to name any companies, but...
Well, sir...